Okay. For adding, subtracting rational expressions, our test will be next Wednesday.
Yay.
Okay.
Okay.
So our test is next Wednesday. Unless you guys want to stay Thursday and finish and do it, I would rather it Thursday, but
I'll do it Thursday.
it would have to be everybody agreed to just stay and finish. So
Yeah, that probably ain't gonna happen.
okay, so let's get going with adding. So when I add, well, first of all, rational is a fraction, yes?
It's in my notes. Yes.
Okay, so a rational expression is just a rational number with a polynomial in the numerator, polynomial in the denominator, correct?
Yeah.
And a polynomial can be 2, right? Or it can be 2x, or it can be really long. When I add these two fractions, what do I have to do?
Make them common denominator.
I have to make them common denominators, and the common denominator between 10 and 15 would be 30. And you get that by taking, this is 2 times 5, and this is 3 times 5, yes? So the actual denominator is 2 times 3 times 5, yes?
Sure.
I mean, that's what happened. That's the math that went behind you going 30. 30 is the least common multiple. We just happen to know that we have 15 and 10. Well, if I had 10x, isn't 10x a factor?
Yes.
Yes, you just don't happen to know what x is yet. So we're not going to do these problems any differently than I would do this problem. We are going to do the same math. We're going to find the factors, and we're going to multiply them. So all the denominators have the same factors, and whatever I multiply the denominator by, I have to multiply the what? Numerator by, and then I have to add or subtract, correct? It's just going to be that my denominators and my numerators have x's in them. That's the only difference. Okay, so I have x over x plus 4 plus 5 over x plus 4. So I don't have one direction up there. Should I need a direction up there?
Direction.
I don't have any directions up there, do I?
Yeah.
Do I have any words?
No.
No. But does the problem tell you what it's doing?
Yes.
What? I'm adding. Yes. I always get somebody go, what am I supposed to do? I don't know. You're supposed to add them. Okay, so it is a fraction. They are rational numbers. I have to have what to be able to add them?
Common denominator.
Common denominator. And they have one. So it's nice. I'm just going to put my common denominator. So I'm just going to take my numerator is going to be just what? X plus 5. Now none of them are going to be that easy. None of them.
I was thinking that would just be 5x, but that's multiplying.
Yes, that would be multiplying. And do we do that sometimes? We know that
Yeah.
sometimes we add when we're supposed to multiply. We just got to remember what. So the next one, well, they would be the same if I distributed, but I'm not going to distribute, I'm going to factor. Okay, so Evan just distributed the right-hand side. But we're not going to distribute, we're going to factor. Everything we're going to factor because we want to know if they have the same factors. Hopefully things will reduce once in a while, stuff like that. So on the left, I will have what? X plus 3. So are they the same denominators?
Yeah.
Yeah, they are. So do I have to multiply the numerators by anything in order to be able to do these two problems? No. So I'm going to have 2x plus 1 plus 3x minus 8 over x times x plus 3. Correct? Just like if I had 30, that's 3 times 2 times 5. But we just combined it to put what? 30. Now, what would I do if I changed this plus right here to a negative? How would this change this problem?
The thing.
Wouldn't that just be x and be 1?
You distribute a negative. To
You
the
distribute a negative through your quantity, and then you combine like terms, right?
2x plus 1 minus 3x plus 8.
Right. So you would just have to distribute that and then combine like terms. So at this point, I just combine like terms, correct?
So it'd be 5x.
minus 7. And if I could factor that numerator, I would, because hopefully someday something will reduce out. I don't remember if it asks you for excluded values or domain, but can I do that as well? Okay, so x can't be what here?
0, -3 and 0.
Oops. -3 and 0. I don't remember, oops, really messing that up. If they say domain, write it as a domain. If they just say state the excluded values, can I just do x cannot be -3 and 0? Yeah. I mean, excluded values means what it can't be. Could you write it as a domain if you'd like? Yes, because it's all the same. If you'd like to keep practicing the domain so you don't forget it, write it as a domain. So obviously they are not all going to have common denominators, correct? Yeah, and that's just not going to continue to happen. Shucks. But I'm going to let you do this one real quick by yourself. Actually, do both of these 2 problems by yourself. Because that one over there you've been doing since like 3rd or 4th grade. On the right. Should have been.
Pretty sure.
You should have been working on it
That was a
for.
long time ago.
But you've been mastering it. You've been working on it. Like you didn't do it in 4th grade and then quit.
Did I?
Well,
You
you
know what?
shouldn't have.
You don't know where I went.
Well,
Where
I
I
did.
went. I was actually kind of good at math then, but now I'm not.
Yes, you are. Positive.
I was gonna say.
Okay, do the problem. Quit talking. Because you're not getting it done.
Not home reduced.
Question. What should I do with my numerator?
Factor out a 3.
I should factor out a 3. Now, can anything reduce? No. But should I factor it out if I can? Yes. Okay, what is my common denominator on the right? 30.
Oh, yeah.
Okay, this is 5 times 6. Yes?
Yeah.
Did anybody tell me it's 180? Anybody in here? You should not be doing that anymore, but sometimes people just go, I'm going to take the left times the right and the right times the left. Okay, could I take 30 times 6 and do 180? But then I'd have to reduce it a lot, right? Now, I may have to reduce it a little, but I'd rather only reduce it what I have to, right? So I multiply 7 by nothing and 5 by what? 5, and get 25 over 30.
So that would be 32.
32 over 30, so 16 over 15. So we still had to reduce, yes,
Just not that.
but by much less than we would have had if we went up to 180.
So you don't want it as 1
What?
So you don't want it as 1
No, I don't want it as 1 and 115. Mixed numbers, the only time I would ever want a mixed number out of you guys is if you were doing like an application problem with your, where you guys were telling somebody like the measurements of something, like the room or something like that. Mixed numbers are completely useless when it comes to math. Can you do anything with a mixed number in math?
You can get mad at it.
You get mad at it. But can you do any operations on a mixed number?
Yeah.
Put it back to the improper fraction.
No, you can't. You have to put it all into an improper fraction and then work with it. So there's really no point.
I mean, if they're both mixed numbers.
If there's both mixed numbers, you could add and subtract them. You could add them definitely, but then you have to carry. And then if you when you simplify, but then when you subtract, you have to remember whole is
Equals
much
hard.
easier to do any math. The only math that you could do with them is add and subtract. Anything else you cannot do.
You'd have to put it.
You have to put it into a mixed number. The only math you could possibly do with an improper fraction is add and subtract, but then you have to follow all the rules that come with it. It is so much easier with an improper fraction. Yes.
How is that gonna work?
I don't know.
Not if you waste time on questions like that.
What? Oh, domain over here.
Yeah, let's do
Okay,
it.
what can't x be over here?
3 over 2.
Negative 3 over 2.
Yeah, negative.
Negative 3 over 2, because you would subtract your 3 and divide by 2. Yep. We didn't have a whole lot of that the other day, did we? I don't know if you have a whole lot of it today, but you will have it. Okay,
For the other one?
the other one was a whole number. The other one is the whole number, right? There's no variable, so there's no restriction on that. Okay, so I have x plus 3 over x minus 1 plus 2 over x squared minus 3x plus 2. So I'm supposed to add these two things, right? And they're fractions, they're rational expressions, so I have to have what? I have to have what? Common denominators, and in order to find that, I'm going to have to factor.
And the second bottom one, we can factor.
Okay, the first one, left we can.
Yeah.
Yeah.
X
Left,
plus
what's
one, X
special about the left?
It's
That's,
a difference of.
Conjugate pairs, difference of squares. That's how it's going to do, right? Well, that kind of rhymed. What is it?
Minus 1 plus 1.
X minus 1, x plus 1. And on the right, so I have 1 as a leading coefficient, so it's going to be, should be fairly easy to do, yes? Okay, so factors of 2 that add to 3.
You would what?
Minus 1, X.
So, remember when we had 10 and 15, right? They both had a common factor, yes? But then we had to bring the other factors from each of the one as well, didn't we? So, what is my common factor that these two have?
X minus 1.
X minus 1. So I'm going to have an x minus 1. I'm good there, yes?
Yeah.
But I also have to have what?
Everything else.
X plus 1
And x minus 2.
and x minus 2.
Oh, yeah, 2, not 3.
Okay. So then we just say, what is the fraction missing, right? So on the left, what is the denominator missing? Yeah, because it has x plus 1, x minus 1. So what is it missing?
X
Minus
minus 2.
2.
X minus 2. So I have to multiply the whole thing by what? X minus 2. Now, whatever this sign is, this is a positive, yes? So we're going to multiply a positive 2, but if it was a negative, we'd multiply a negative 2. So the fraction on the right, or the rational number,
X plus 1.
it's missing an x plus 1. Does everyone see that?
Yeah.
So I need to multiply by what?
2x plus 2.
It's going to be,
Gonna be.
yes, but it's not going to. Okay, so on the left I've got a FOIL, right? So x squared
Plus. Well, no, minus 6.
no, minus 6.
Yeah.
Oh, that minus 6. I thought you were telling me minus 6x. Okay, and on the right,
2x plus 2.
now if it was me doing my paper, I would just have x right here. I would not have 3x minus 2x because I multiplied in my head, right? Does it matter if I wrote both of them? No, because my next step is going to be what?
Combine like terms.
Combine like terms.
So the
So,
x squared plus
Nothing.
3x. No, I did one. No, that's
Yeah, you're right.
3x, 3x,
Yep.
because the negative 2 and 2 are gone. And then minus 4. Now, I'm just going to draw a line here because of the fact that I said I need to keep factoring if I can factor, right?
Yeah, and you can factor
And
it
I don't
in.
want to rewrite the denominator. If you want to rewrite the denominator, you go for it. But when I notice I can factor the numerator, I just draw a line and then skip a line because I don't want to rewrite my denominator. That's gross. That's a lot of time, right? Actually,
So
I'll do it
maybe-
because I don't have a lot of room. But I would do that. I don't have a lot of room. So what is the numerator factor to? Kale, don't say it.
What's it factored?
Yeah, the numerator. The factors of 4 that have a difference of 3.
X plus 4, X minus 1.
Okay, so this is going to be x minus 1 and x plus 4. So, can I reduce anything?
Yes.
Yes.
The X minus 1.
The x minus 1 reduces, and I'm left with x plus 4. And put those parentheses so you don't try to reduce when you can't. Over x plus 1 times x
Plus
minus 2. And x can't be, I don't have a whole lot of room, but what can x be?
-1, 0, or 2, not 0. -1,
Negative 4, positive 2.
-2, -1, and 1.
No.
Here, we had everybody half right. You
Negative
look at that.
1, 1,
Okay,
and
look
2.
at the denominator right here.
-1, 1, and 2.
Yep.
Yeah.
Plus or minus 1.
Ah, in your face.
He'll have it. Where'd you get 4, Elena?
I was looking at the wrong thing.
Oh, okay. Oh, you looked at the numerator?
Yeah.
Okay. So this is still just the denominator, right?
Yes.
Not too bad. Are there multiple steps to it?
Yeah.
Yeah. But is it just what you were doing before with the 15 and the 10?
Yeah.
Exactly what you were doing with 15 and 10, but we have x minus 4 and x minus 2. So do you have to slow down a little bit?
Yeah.
No.
Yeah. Okay. So, gotta add. I got rational expressions, so I need to get common denominators, and in order to do that, I have to factor. Now, you do not need to factor the numerator, do you? No. Not unless you think that, like, if I thought these two could reduce, could I factor the numerator and see? Yeah, but
They can't reduce.
I don't know if they can or not.
They-
Factors of 48 that have a difference of 11.
Well, positive, negative 12 and positive 1.
16. No, factors of 48.
Oh,
You have to do the 4 times the 12.
oh, whoops.
I can't think of any factors of 48.
7 and 6. That's 13.
No. What'd you say? 16 and what? 3? 16 and 3 would be 13. So, I don't want to waste my time. Do you guys want to waste your time?
No.
I can do it later. Okay, because I can factor this. Now this one I'm going to have to take 6 times 4, correct?
Yeah.
Okay, so negative 6, not 64. How about negative 24?
Yeah. Factors.
Okay, now factors of 24 that have a difference of 5.
8, 3.
8 and 3. So it's going to be positive 3, positive 8,
Positive 8.
negative 3. Now, do we need to go through the whole factor by grouping? Yes? Probably? Okay, so these two replace this, yes?
Right.
So I have 6x squared plus 8x minus 3x minus 4. I'm just going to group the first two. You can group them the other way, but I'm just going to group the first two. What do they have in common? And,
X.
so 2x. So that gives me
X.
3x plus 4. And these two I'm going to factor out a negative. And so I have 3x plus 4. So the whole thing reduces to 2x minus 1 and 3x plus 4. So now I have this and this. So do I have a common factor between the two of them?
Yes.
Yeah. Okay, so my common factor between the two of them is 3x plus 4.
Yes.
And the other factor I have to bring is 2x minus 1. Now, this left fraction, rational expression, do I have to multiply it by anything? Am I going too fast?
A little bit.
You don't.
On the right, do I have both things in the common denominator as I do in the denominator?
Yeah.
I said right, but I meant left. I'm pointing left. Left. I'm good, right? So do I need to multiply it by anything? No, I'm just going to do what?
Write it down.
Write it down. Okay. Now this is positive 2x. If I was subtracting, it would be what? Negative 2x. What do I need to multiply 2x by?
2x minus
2x minus 1. Why do I need to multiply by 2x minus 1?
1. Because 3x plus 4 is already in the denominator.
Because 3x plus 4 is already in the denominator. 2x minus 1 is the factor that's missing from that fraction. Correct? So I distribute the 2x, and hopefully you would get 4x squared minus 2x.
Give it back out of it too.
Well, no, you have to combine like terms before you do any factoring.
And there's an 11. So
Yeah, and there's 11, and yes, you cannot do that. Okay,
So it'd be
so it would be
8x
I meant for that part. the
8x
last
squared.
minus 13x
Yeah, I'm okay with minus 13x,
minus 12.
and then minus 12.
And that you can, oh wait, never mind. It's gonna give him to do that.
It's going to be the factors in 96 that have a difference of 13.
Yep.
I'll get it.
Last hour we thought about it a little bit.
Keep going. I think we should do the quadratic formula.
What good would that do? Because the whole point is to reduce, right? And if we can't reduce it, we're not solving it yet. That's Monday.
No.
why is adding and subtracting so much harder than multiplying?
Because you have to get common denominators. It's just another, that's it. That's the only thing. Yes, Elena?
So the denominator would be x cannot equal positive 1/2 and negative 4/3.
Good job. My domain, what is the excluded values? If I say excluded values or domain, I'm asking you for the same thing, right? Why can't those numbers be included?
Because they are the asymptotes.
They're the asymptotes. Why are they asymptotes? Why are they vertical asymptotes?
Because they
They just want to
because they just are.
What do they do to the denominators, guys?
They make them.
make them 0.
They make them 0, and can we divide by 0? No. Okay, I'm always gonna ask you why, because if we don't know why we're doing something, is there any reason to do it? No. And if are we ever gonna remember it if I don't tell you why you're doing it?
Yes.
I doubt it. Not past the test, at least. And everything here, I hope you remember at least this much of it, so we have something to start with next year. Because if you don't,
Do we ever finish the last part?
it's done. We decided that that's not factorable in the numerator, right?
It is.
It is factorable.
I'm sure it is.
Well,
It's gotta be.
No, Evan. look
okay,
at me.
8 and 12, right?
Yeah.
And this is 2, 2, 2, 2, 2, 3. I just broke it down, prime factorization. That's what I got, right? That's what I can move around. I need to multiply them together and get a difference of 13. So if I bring this 2 over here, this makes this 16 and 6. 16, 6, and, right? Now if I bring all of them over, I get 64 and 3. No.
Close enough.
Yep.
Let's see, 4 is 12 and 8. No, we just did 12 and 8. 6 and 16.
No.
I don't think it is.
But if I looked it up, there would be something there.
Okay, we'll look it up later.
Okay.
Okay, so what am I doing now?
Subtracting.
Subtracting. Am I gonna do this anything different?
No.
No, except I have to distribute a negative, don't I?
Uh-huh.
I cannot forget to distribute a negative. So, first thing I'm gonna do is what?
Find the common denominator.
Find a common denominator. How are you gonna do that? Factor. Factors of 16 that have a difference of 6.
So 3 and 6.
I can
No,
do
no. I'm just speaking on 2 and 3. I'm doing 8.
Okay. So I have x minus 8, x plus 2.
Yep.
Factors of 8 that add to 6.
4 and 2.
1 and 2. Now, do they have to have any common factors?
It'd be
No.
nice.
That'd be nice.
But it does
It'd
have
be
one.
nice, but if they don't have any common factors, we're gonna have some fun multiplying, right?
X plus 2.
Okay, so my common factor is what?
X plus 2.
X plus 2. And I need to bring along
X
x
minus
minus 8 and
X plus 4.
x plus 4. So what do I need to multiply the left by?
X plus 4.
Now, I'm going to tell you something I do, so I don't forget to do it. At this point, I distribute a negative before I even start into this quantity that's on the right. Nope, you get what I'm saying? Because if I distribute the negative now, do I have to remember to do it later?
No.
No. So this is a quantity, and I have a negative, so it's going to be negative x minus 1, correct?
Yeah.
And what do I need to multiply by?
Negative 8. X minus 8.
X minus 8. So now I just need to FOIL, correct?
Yeah.
Okay, so I get x squared. I would have 1x plus 4x, so it would be 5x. Everyone follow how I got 5x right there, right?
No.
1x and 4x. Remember that middle term is the outer and the inner? And then plus 4. I just knew I wasn't going to have a whole lot of room to keep going. Okay, and then I'm going to have minus x squared, aren't I? And then this would give me positive 8, and this would be negative 1, so it would be plus 7. And then negative 1, negative 8 would be positive 8. If you can remember to distribute that negative before you do that second distributive property, it makes the don't forgets much less. Does that make sense? Much fewer? Yes, Elena?
And you'll only distribute the negative on the numerator?
Yes. Because if I took it on the numerator and the denominator, that'd be a negative over a negative, which is a positive. So that negative goes numerator, or I could put it with the denominator, but that's usually not something we like to do. We mess it up most of the time. Yes.
Okay, so I went on and I got the.
Oh, okay. So my x squared and x squared reduce out, yes?
Yeah.
Okay, so then that gives me what, 12x plus 12? Okay, so I can factor that, right? So
Yeah,
this
you
is
got
where
12.
I'm going to just put the big line normally. And so this is going to be 12 and then x plus 1, isn't it?
Yeah.
So what can I do?
Nothing.
Nothing. Oh, shoot, I can't. I'm wasting my time. I was hoping I'd have it. If I had an x plus 1 down here, could I reduce it?
Yeah.
Yeah. If I had a constant out here, could I reduce it if it was even? Or
Yeah.
so my answer is going to be 12 x plus 1. And x can't equal what?
X can't equal
Negative 2, negative 4, negative 2.
Negative 4,
negative 2,
negative 2, and 8. It's not that bad if you don't try to do it all at once, is it?
Yeah.
When you see the problems, they look horrible because you think, I got to do this all at one time. I'm going to tell you guys, I've been doing this for a long time, and I cannot do this problem any differently than I just did it with you. Promise. That's it. Okay, you think you can do this next one on your own? You want to see? Really?
Oh, we can give her a shot.
I can attempt it. No,
Don't do this to me.
Right.
It froze it.
Get out the marker.
You guys try to work on the problem while I try to fix the issue. Yeah, on here I have like 6 lines.
Oh.
There it goes.
Okay.
That looks cool though. Oh my gosh. It's plus and minus.
I have a plus and a minus. At least you don't have to factor.
No, but you gotta get a common denominator.
Yeah, but it's not that hard.
Yeah.
What's your common denominator?
6.
6x squared.
No, well.
Because the 6 has has a 2 and a 3, yes?
Yeah.
And the X has an X and an X. So if you think about it, just the same as we did, what do they have all in common?
6.
Actually, nothing. There's not one thing they all have in common, is there?
No.
No. But I have to have two. I have to have X squared, don't
I
I?
mean, it has the 3.
Well, 2 of them have something in common, and 2 of them have something in common, but they don't all have something in common.
Oh, they all have an X.
No. Oh, they do all have an X. My brain was like not even seeing it. Okay, so we have to have X squared because we have to have the biggest one, right? And then we have to have 6. So what are we going to multiply first one by?
2X.
2x. What are we going to multiply the second one by?
X.
And what are we going to multiply the third one by?
6.
6.
And we're gonna distribute an
Well, it's just negative 1 times 6.
8.
I did negative 1 times 6. Did you guys do negative 1 times 6?
Yeah.
Well, hopefully.
Oh,
Why did I do negative 1 times 6?
Because it's a minus 2.
Okay, and then what?
And then you can back
You factor the numerator.
3 and 2.
Add your 2X plus X. Oh.
So I have 3x minus 6 over 6x squared.
You can factor out a
I can factor out a 3. And because I can factor out a 3, I can reduce what?
The bottom one.
I can reduce to 3. But could I do that before I factor?
No.
No. Because it has to be product to be able to reduce, doesn't it? So then I have what? X minus 6 over 2x squared?
Yes.
And
Mm.
x cannot equal what?
2x.
No.
Well, plus
Six.
minus.
No.
-6.
No.
You guys got it. It'll be fine. 0.
0?
I don't know.
Like,
Well, okay, first of all,
Because
it should be
I
X
have-
minus 2.
Yeah.
What?
It should be X minus 2 over 2X plus 2.
Oh, yes, this should have been a 2. Sorry. I apologize. Because I only factored out the first one, not both, right? But why can't it be 0?
That's it.
And I guess if you want to think about it, can't be plus or minus 0, but that's just still what? 0. It's not plus or minus 0.
oh, because
There is plus or minus 0 when I'm thinking like if it's a intercept, right? So it would be a double, so it bounce. But other than that, we just write 0.
big fat donut.
Huh?
Oh my gosh, there's a fraction.
Don't worry about it. We're not even to that problem yet. Okay,
I thought you did
left.
that fraction.
focus on the left.
Isaiah, what? Oh, Jim, say something.
Okay, 3x minus 5 over x squared minus 25 minus 2 over x plus 5. I think I want you guys to try this one on your own.
Okay. I cannot think of
I think that'll
You're going to make that 2 a what?
Negative.
Negative 2.
Yeah.
Okay, well, you can.
Write it on your paper. Okay. I guess I can't do anything about it.
And a note to that.
Get the water off of it.
You guys ready for me to start? Can I start? Just don't look up if you want to see, right? did it go?
Well,
How did you
I
get that
didn't
one?
reduce x plus 5. But otherwise,
How did you get that one?
Because I have x plus 5 in the numerator and x plus 5 in the denominator, and when they reduce, what do I get?
1.
See, I had it right. I just forgot how to take the
Wait, what?
x plus 5 times negative 2. But x minus
You
5
should've
times
taken
2. Like you
3x
forget you have to
minus
do that.
5 times
Negative 2. And I did.
negative 2.
Yes.
Why didn't you do that? You should have done it by,
Distribute the negative.
oh my gosh, I'm stupid.
No, you're not stupid.
Oh, you just did a stupid thing.
Gotta get that negative. When you write your problem, if you want to do this, when I write my problem on my page, could I do this?
You wanted to.
Yeah, I hate the add a line, change a sign thing. I hate it.
Huh?
But in this case,
I don't want you.
yeah, don't even do that. You need to move that negative. You need to connect that negative with something you're not going to forget. Okay? And I could show you how to put it into this step, but I don't want you to put it into this step and then have to distribute a negative, and then I don't want to put more steps in your steps. Does that make sense?
Yeah.
Let's do it when it's efficient to do it. How did it go?
Well, first off, I multiplied the 3x minus 5 times the negative. No, thing.
Okay, the 3x,
Put it out.
the 3x minus 5, did I have to multiply it by anything?
No, 'cause both
No,
are active
because it
drawings.
hasn't.
Yeah, I,
Okay, so what we did over here is he did the classic case of I have 10 and 15 and made its common denominator 150.
no,
Because yes, you did. Because you multiplied both of them by each other.
I didn't.
Oh, okay.
You
So,
messed it all up.
Make sure you're only doing what you have to do. In general, how did it go for you?
Pretty decent.
What was it?
Well, I had it kind of, but then I didn't. After I put the x minus 5 on the other side, I didn't put it in my denominator. But then by the time that I figured out that I had to do that, I looked up and the rest was already worked out.
Well, you didn't have to look up. Don't.
Are we gonna work out that last?
Yep, we have two. We have actually got 3. Okay, but I want us to get us completely done with this. I don't want anybody's brain on the other problem. Okay. Now, on the right, write it down while I'm talking. When you are dealing with these, they're called complex rational expressions. Can you tell why they are complex?
Yes.
Okay, because there's a fraction in the numerator, a fraction in the denominator. You can have fractions in both. A division bar is just a grouping symbol. We've discussed this before. This is one big division sign, yes?
Yes.
And it says I have to do the top,
By the
I have to do the bottom, then I have to multiply by the reciprocal. That's what we're going to do. You have 2 individual problems. You cannot, I cannot, even on a good day, after I've been doing them for a year in a row, could look at that problem and tell you the answer. Got me? It takes time. It takes steps. Just like these are the steps you'd have to take, these are the steps I would have to take as well. Now I may be able to like cut out a few of these in the middle, but I still have to do the procedure. Does that make sense? Okay, so when you look at these, please, if you need to, write it down and cover up the bottom. Like put your hand on it so you can't see it. Because if your brain is trying to look at that at one time, it is leaving the building and accomplishing nothing. So if I look at just the top, it shouldn't be too bad, should it? This is x, and this is x plus 1. So my common denominator would just be what? X times x plus 1. Now, why isn't it just x plus 1? Because that's multiplied, yes? That x plus 1 is a 6. I can't take it apart, can I? So my common denominator in the numerator is x times x plus 1. So what do I have to multiply the left by? X plus 1. And what do I have to multiply the right by?
X.
X. So I have what?
X plus 1. Yeah, 3x plus 1.
3x plus 1 over x times x plus 1. Yes?
Yep.
Is the denominator in the actual problem one fraction? Is it one fraction? Yes. So it doesn't need to be simplified, does it?
No.
So when I divide, I now multiply by the what? Reciprocal. Which is
Y over one.
y over 1. Now, I can reduce up and down and diagonally. Is there anything up and down and diagonally I can reduce?
No.
Nope. So I have y times 3x plus 1 over x times x plus 1. And x can't equal what?
-1.
And
0.
0.
That wasn't that hard.
No, it wasn't. And they're not that hard.
Look at me again. Good, Kale. That's what you
Okay.
deserve.
They are not that hard if I do the numerator, do the denominator, and then multiply by the what? Reciprocal. That is what you're going to do. Simplify the numerator, simplify the denominator, and then multiply by the reciprocal. If you try to do that, can I do that all at once? No, it is impossible.
Okay.
We're gonna get more.
Oh, no.
Hello.
Okay, don't. Guys, you just psyched yourself out. This is the numerator. Look at it. Is that hard?
No.
Is it done?
Yeah.
Yeah. And the denominator. Is that gonna be that hard? No.
But you
Stop.
know the
Don't worry how big the problem looks like. Look at the pieces. It's not one problem.
Doesn't that cross cancel?
There is no such thing as cross cancel, nothing.
Miss Possible taught us
Okay, Miss Poss is not here. Mrs. Mick is the person you have to live with for the next 2 years.
that. Okay, can you
So-
like diagonally
Reduce.
Cross one.
Yeah.
Okay, is that multiplication?
I didn't say that.
I'm asking, is it multiplication?
Reduce
No.
though.
No. Can you reduce when you're adding fractions diagonally? No. Can you reduce up and down all the time?
Not
Yes.
when you're asking, not when you're applying and dividing.
Yes, man.
Reciprocate it.
You said that.
Okay, so the numerator is accomplished, yes?
Yes.
It's one fraction. The denominator needs to get there. So what is my common denominator going to be in the denominator?
X minus.
This is one
3x.
thing. So it's going to be 3
3
times
x
x minus 1. Because we have 3 and 1 and we have x minus 1. X minus 1 is one thing. I can't do anything with it, can I?
No.
Put those parentheses to make sure your brain knows it's one thing. So what do I need to multiply the left by?
X minus 1.
X minus 1, because I have a 3. And this is a quantity, so I'm going to have to distribute, yes?
Yes.
So that is going to be x squared minus
X.
2x
2x. Wait, where did you?
plus 1. Negative 1 and negative 1.
Oh.
Outside, inside. If you need to write it all out, can you write it all out? Yes. If you need to write negative x, negative x.
Don't you need a more?
Now,
Of 1. X minus 1 is 1.
I need to multiply the 4 by what?
Oh, yeah.
3.
3.
So,
Oh, yeah, not 3. I said 3 and I wrote 3. Okay, so I'm going to put that to 13, yes?
yes.
Yeah.
Okay,
So back to
now,
the-
is the numerator one fraction?
Yeah.
Yeah.
Is the denominator one fraction?
Yeah.
Now I multiply by the reciprocal of which one? The denominator. There is no bottom, there is no top. There's a numerator, there's a denominator.
Whatever.
Okay, so 1 over x minus 1 times what?
Times
3
3
x minus 1
x minus
over x squared minus 2x plus 13.
Whoa.
And this over here is one thing, this x minus 1. Now, I should think about, can I factor? Are there any factors of 13 that add to 2?
No.
Okay, reduce up and down diagonal. x minus 1 and x minus 1. So I have 3 over x squared minus 2x plus 13. And we're just, this would be an unreal solution, so x can't be what?
X can't be zero.
X can't be,
Zero.
no.
X
Why?
one.
Where are you getting the 0 from?
From the x squared probably.
No, the x squared, that would be an unreal solution, correct? That'd be imaginary?
Yeah.
Yeah? Okay, now this one isn't really even that bad either. This 2 is over what? The 2 is over 1, yes? And this x is over what? 1. What's my common denominator up here? X. So I'd multiply the 2 by what? X. 2x minus 1. What would my common denominator be in the denominator? X. So I'd multiply x by what?
X.
X by x.
Oh.
Yes? So it'd be x squared. And what would I multiply 2 by? Nothing.
Oh, wait.
It has an x.
Oh, yeah.
Now what?
You reciprocate and multiply.
Different.
The denominator.
And what can I do?
Reduce the x's.
And x can't be 0. Because this would be an imaginary with the 2, right? You'd have a square root of a negative number. Now, what do you notice up here and what reduced out? They both have the same denominator. I'm going to tell you, anytime this happens, when the denominator of the numerator is the same as the denominator of the denominator, they will reduce out when you multiply by the reciprocal every single time. And so you can just put what? Numerator over numerator.
Oh,